So I want to start implementing generics type checking in the current compiler, or in the new compiler, I should say. It just skips generic functions currently. So the way that generics are handled in the existing compiler is it's a little bit tricky. It's a little bit confusing. So the way I'm going to handle it in the new compiler is basically a generic function will get monomorphized, I think is the right word, into a concrete function with the correct types. So basically any stages coming after the type checker, like IR stages, generation, machine code generation, whatever it may be, can treat the generic functions just like a normal function. This simplifies things greatly. It's not their concern about generics. It shouldn't be their concern about it. They should just be able to treat it like a normal function and everything should behave normally. But I will keep some type of metadata attached to the function so that which will say that this function is the concrete version of a generic function, if that makes sense. I'm not sure exactly how I'm going to go about this, but I have a general idea. Just gonna start trying to make it work. But first, there's a couple of obstacles I'm going to have to get past. I'm trying a different setup at the moment, different terminal. Well, I'm trying my normal terminal. Before I was trying a different terminal. Anyway, I think my color scheme's a bit off, but it'll do for now. All right, so this is where I was doing this error here is because of smart casting. I've done smart casting on identifiers, but not on selectors. So this is the selector here. Actually, I did start to implement it, but it's not finished. So we're not going to worry about this for now because we're going to re-enable generic function checking. Actually, let me, oh yeah, the font size was, hopefully that font size is big enough. Anyway, let's see. So generic functions currently just skipped, so let's not do that. It skips right here, so we'll comment out this check here. And we're going to find when we do this, we're going to just exit with no error, if I recall correctly. Yes, so we've exited with no error. So something's happened. This is a crash. Some type of infinite recursion is happening. So I'm just going to have to track that down before I can continue. So, I mean, what we can do is, we were at expression, selector expression, and this rand file. Let's have a look at that. We're at 453. And well, that's it. Also, generic structs, I'm not so much going to worry about that at this particular moment. I'm just more doing generic, well, I mean, it's all part of it because obviously it's to do with the generic function, but I'm just going to start by doing the function method part of it, and then the structs we'll do later, struct instantiation and things like that. But just need to figure out why this is crashing. So let us see, we're in a selector expression. We probably never got out of this selector for some reason. So looks like we're on, let's add some debugging so we can see exactly where we are. So let's print the, let's do expression dot name. I think I added a method that will get us like a short little name, and then let's do the expression dot right hand side dot name, because right hand side of a selector is always an identifier. It's not an expression, which makes things nice and simple. And look, the behavior has changed, and that's just because it's a crash. It's unpredictable behavior, so we don't exactly know what's going on here. And we have it's quite annoying. Missing. Look at this. Oh dear. This is just junk. We don't know. We're not going to worry about that because something's happened. You know, I can't actually believe that this is true at the moment. Let's see. Good morning from Australia. Hello, my German friends. Guten Tag. I wish I had a better way to debug this, like without setting some breakpoints and stepping through it manually or something like that. Let's look at the LLDB and see what happens, just out of interest. Let's do all this. Let's do these null anyway. Oh. Where's the command? V. No, this is just a. This is even another error now. This is not the. I don't believe that this is This is truly what's happened. See, look at this. Oh, is this the same thing? I need to do something for 10 minutes, 15 minutes. Should I leave the stream open or should I close the stream and come back to the stream? Oops. Oh, you can see here that it was segfaulting. So identifies array, selector expression. Let's add the name to the selector. Let's do. I want to try and not modify the. I want it to crash in the same place, but if possible. So it is a len. So it's this. It's here. We're here. Okay. I've returned. Sorry about that. Family stuff, so I couldn't really help it. Hey Skylord, I'm working on generics in the type checker for the new V compiler. As I explained earlier, generics in the new compiler will be, functions will get monomorphized into a concrete version of the generic function. That way, later stages after the type checker will see that function and treat it just like a normal function or method. They won't have to do any special stuff. To the later stages, it will just look like a normal function. This simplifies things a lot compared to the current approach. So at the moment, just working on the type checker, generics, and the type checker. Because at the moment, generic functions are completely skipped. So I've stopped them from being skipped, and we're getting a seg fault. Some type of infinite recursion is happening, so I'm just going to track that down. So we're getting a seg fault somewhere after checking this. So it's obviously one of these. It's one of these. Let's have a little look-see why. So let's go to the... So it might think this is... I wonder if I have a type for that yet. Let me think. Let me check the AST. Init, array init. I might need a special... It could just be getting passed as a struct init at the moment. Instead of like... this doesn't necessarily know what it could be. I mean, we've got the len field, so you could, obviously, I mean... Oh, wait, these are arrays, so my bad, but... If it wasn't an array, it'd be hard to tell exactly if T could be a map, or something. But obviously these are arrays, and never mind what I was saying about that. Let's go to array init, see if we get there. So we never got to the array init. So somewhere between here and here, we're segfaulting, going to infinite recursion. It could be... Sorry about that. It's not Python. It's yes, it is a custom language called V. It's a V language. Okay, so we never got to the array init. So we're stuck somewhere in the selector for, where is it? For this 453 we got here. Looks like we never got here. So we've got here, we got here. Let's have a look at the okay. array.learn, yep. So type, see if we got to here. Okay. Oh yeah, here we go. This is the recursion. Looking for field method length on string. So because we're looking up, let's see what's happening. Because of these, this is a generic. Okay, what's going on here? So we look up the array. And we look up, keeps calling this method, but it should error. Let's see. So it's finding it. It should be returning it. So it's falling down to here. My method. Why isn't it erroring? What's going on here? What's in the else branch of this? Else. Why are we doing this? Very strange. Oh, the cursor increases if I move the mouse erratically. It's a macOS feature, but it's good for highlighting stuff like that. If you move left to right semi-fast, it does it. I think I don't know if it's on by default in macOS or I accidentally turned it on, but I don't mind it. It's good for streaming. Okay, why is this happening? This is annoying. Let's have a look at this. Let's go to the end. let's see if let's look for found. Okay, we never even got to here. So it's looking up. Never found it. Looks up the method. Never found it. We should error. We should be erroring. Why have we gone into recursion? Strange. Strange. We never even got to the method lookup. Ah. What is going on here? This is bizarre. Did I save that? Okay, so we got to here. Method. Is it okay? It's just going into recursion right here. Why is it doing that? So this is T, array of type T. If T is, which is an array, so it's dump T. What is this? String. What is this? String. Why does it even think it's string? What is going on? Okay, let's a bit confused now. Should find this. Oh, hang on a minute. We're looking on the array type. Oh, this is something else. for field or method length on string. This is ridiculous. This is so annoying. What on earth is going on here? Where's this string coming from? I don't have any context here. Selector expression. Hang on a minute. Maintain name. It's looking on the array type, so it's not finding it. Why isn't it finding it? This makes no sense. Unless this scope is stuffed up. Let us dump. It's very, 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 very strange. I mean, it's very strange it hasn't happened before. Length on string. And where is string coming from? This is rather frustrating. Why hasn't this happened before? Clone. No, that's nothing to do with it. Should find this. I didn't get it. Let's just print the method. Let's look at the field. Something's wrong here. Let's do a. Okay, let's. Okay. No, we don't have any fields. Hang on a minute, what's going on here? I think I know what's going on. Hang on a minute. Data offset len. We have the we have a len field. Okay. We have it. I know. Now, where is it? Right before we go into the. Right before we go into this. Oops. What do I do? How do I swap them? Oh, that's better. Right before I go into this loop, let's see. So, where is it? Here. Okay. We have it. We have a length field. So now what's happened? We've gone down, down, down. Okay, and this time it doesn't find it. Strange. But why does it even think it's a string? Let's look at the file again. Was it 453? There is no... Why would it think that is string? If t.name equals string, let's dump the scope. Hang on. What line are we at? 204,800. Okay. So the scope here, we have A, config, and RNG in the current scope when that's happening. A, config, RNG. Okay. So we're not even in here. We are not in here. Config, RNG. Looks like we're, Config, RNG. A, what is A? A could be 20. Firing on strings. Now, sorry, I was looking in the wrong place. What? How are we even getting this? We're not printing the... Something's wrong here. Yeah, that's better. So, it's an array. The type was array. Hi. Oh, that's good to hear, Mike. I'm glad you're enjoying it. I really like it. Like, I like the simplicity of it. I really hope it stays simple. I like the syntax. I like the interoperability with C. And there's a couple of little things, that could be improved. And I think if we nail those things down, it's going to be a top tier language. Like, if you can make it rock solid, I think it's got a bright future. And I want to, with the new compiler, I want to have, we're going to have a, like the current compiler goes from AST straight to C with no IR. So the new compiler is going to have an IR, SSA based IR. And that's going to allow, obviously, it's going to be a lot easier to go to machine code because it's just easier that way, basically. You're only handling a certain amount of instructions. Like, you could think of them like assembly instructions. And once you implement those instructions, then the code is basically just combinations of those instructions used together. That's an oversimplification, but basically it makes things a lot cleaner. And also, I want to go from that. Either we could operate on that directly, but I want to go maybe to bytecode and create a virtual machine for the interpreter. So it'll have its own interpreter. And the beauty of that is it will allow like rich compile time features, like compile time code execution. So you'll be able to execute any code at compile time. So it'll give you like powerful sort of macros in a way, but you could run a full program at compile time. So let's say you wanted to, whatever type of, like if you wanted to build configurations or options based on operating system or any type of heavy lifting you wanted to do at compile time rather than at runtime, you can do that using just the language itself. So that will be a beautiful feature. So that's another one of the aims with the new compiler. Oh, that's cool. Davros. So what on earth is going on here? So we have the array string. Shit, sure it's an array, yes, as I suspected. So I don't understand why this is failing. This shouldn't fail for length. It should exist. Well, let's just. This is crazy. This makes no sense. Name equals len. Let's return. Let's return. Return type. Let's call it int. Yeah, did I remove scope from there? Okay, so if I manually do it, it's worked. It doesn't make sense why it's not finding it. So I have an idea. Let me try something. Array. I know what it could be. I think I know what's going on. Was it 443? All right, this is the problem. It's the name of this. So okay, all right. So let me try something. If I get rid of this code that I just added, now here, this is annoying. That is annoying. Okay. Instead of here, let's do universe. Let's do built-in built-in scope, because we were overriding array. You see here, array has been overridden in the scope. So we're looking up the type array and getting back this variable. So if I look at it directly up, if I look at it directly from the built-in scope and upwards, I should remove the error. What's going on here? Or maybe built-in scope's not. Maybe it's not a thing. Let me just do it on universe. Actually, no, it's in built-in. Let me have a look. See, so let's add built-in scope to checker. Let's just add that. Let's just do c dot built-in scope. Okay. Let's add just do built-in scope. Okay. Where is it? Okay, here we go. So that should work now. Oop. Okay. All right, that's better. What line is this? 4082. Okay, that should work now, I think. Okay, beautiful. That works now. We can get rid of this junk. That was the reason for the recursion anyway. So we'll look at it. Yeah. Actually, I should do the same thing here. See, we will fix this stuff. See, this shouldn't be needed. These lookups, but it's just the way that it's way that these things are described are defined in built-in, that we need this. It's kind of a bit, it's not the nicest way, but we can't really avoid that at the moment. Okay, so we should be checking generic functions. Okay. Generic bodies. Declaration. So types shall be registered by this time. So so let's go to call expression. Well, firstly and foremost, this what we'll do is make a simple case. Let's have a look at one of the generics tests. Generic method. Generic function. I mean, there's a lot of tests here. Generic function. Oh, with reference arguments. Well, let's just try this one or something. Let's just try that that test. Okay. That's annoying. Let's make our own little generics tests. Okay, let's just do new. Let's do struct. Actually, let's save this to tests. Let's do generics. Let's do generics, generic functions of a. Okay, let's do function generic function a. Let's say t. So let's just print. Let's do param a is t, param b can be int. Let's just print param a. Let's add a few more complicated ones. Let's do y. B, C. Let's make this an array. And we can make this a map or something. Let's make this a map of y, t, something like that. Let's do let's go a. let's leave this uncommented out for now. Oop. Now let's get these two working first. I mean, we can add an array in here. Let's do A equals T. Let's do B equals map. Let's do map Y int. Let's do C map Y T. Let's do T int. Okay, let's just try these little basic tests here. Let's try oops. What did I do? Okay, let's call let's do so we can infer them, like that will be automatically inferring the generic types, or we could list them manually. So like int string. Now I'm pretty sure both ways are still supported. I need to double check that. Let me just check that quickly. I think they are. Let's do T. Okay, let's do function A. Let's do int 1. Well, it doesn't work in this in this script mode thing. So let's just call this one a V. What is this? This was some. Oh, this is the output of our. Never mind that. Let's call this gen1.v. Let's just copy this. Actually, let's just run our test in normal V. Let's see what happens here. What have I done? Undefined ident A on 11. Oh, it's for RAM A, I've called it. I should have dumped it really, but can I use string as int not given to generic function? What have I done? Oh, okay, I've done it. Huh. Well, that's a bug. What is this? Expected 1 generic parameter, got 2. What is this? A. Oh, here we go. That's why. It should be A doesn't need. A's only got 1. can I use string as into argument 2, 1. So this is that should be B. Hang on a minute. Let me use string as into argument 2. Something weird. Oh, this is an int. Huh. Let's make that string. Okay, so we got 1, B. Okay, so this should be int, and let's call it string. Okay. Okay, so that works. Just basically, we should use dump here, maybe, so we can see the type. Well, that's irrelevant. It's not going to work with the new compiler anyway. Well, it doesn't show much anyway. It doesn't show the type. Anyway, so let's get this to pass in the new compiler. So okay, so we have passed, and look at that type checking time. That's because we're printing all this stuff. If I get rid of that, it should knock it right down. So basically we have passed it with no errors, so something is wrong. We're not checking arguments, so let us start by doing that. Let's go to call expression. Let me check the comments. No, hello Neil and dude. I personally haven't, no. All right, so let's go to call expression, and we're not actually checking the, as far as I remember, we're not checking all the arguments. So we are checking, we're not. So let's do that. This is all to do with compiler no. Let's ignore that. That stuff's got to go. This is to do with compiler magic. A lot of this stuff will go. This was I'm not sure exactly what this was for. I'll leave it there for now. I'll clean all this stuff up. So let's check the arguments. Let's do for param. Actually, they're called arguments here. For arg in expression.args. And once we check these, we'll start to see some errors, I'm pretty sure. Let's do c.expression arg. No errors. Interesting. Let's dump the output of what we've passed. Let's dump it to, wait a minute, what's going on? That's a whole bunch of stuff, because let's dump it to 1.v. Let's run it with skip built-in and skip, actually, well, just for this I'll run it like that, skip imports. Okay. Well, now we're getting print line is unknown because I skipped that stuff. But let's disable type checking for a minute. Okay, let's see what the past this is what it got passed as. Okay, this all looks good. We'll see that this was passed as generic arguments, but this one was passed as generic args or index expression. Now the reason we can say, I'll explain that a little bit. This one here, because it's got more than one, it knows that it has to be generic arguments. Okay, it can't be an index expression. Now this one here, it's a single, okay, it's an int, so we know it's a type, but the parser doesn't care about types. So that only comes in the checker stage. So parser doesn't care about that. It could be anything. It could be T, it could be anything. It just looks at that as an identifier. So to the parser, this could be an index expression. It could be an array of functions and we're calling it. So this is why this one is generic arg or index expression. And then the type checker resolves what exactly it is. Okay, so it's passed. Now, I'm surprised we're not getting any errors. So are we type checking these functions? Let's enable the type checker again. Let's make sure it's, let's do function declaration. Okay, so let's do a little print here. Oh, what happened there? Print line, let's do deferred. This is this gets deferred, the checking of the function body. Now let's do function declare.name. So let's see if it's actually running. What is it? Oh, oh. So what was it? Deferred. That's weird. Okay, so F64 from bits. Okay, so these are all deferred functions. Let's have a look for some generic ones. I'll tell you. So let's do if where is it? If function degal the generic params length is greater than 0, should be a generic function. Oh. Preferred generic function generic strange. I don't have that there. Let's go to the parser. So where are the generic parameters passed? LCBR. LCBR here, no. LSBR should be LSBR. Okay, here we go. Generic params. Now I thought these were saved onto the struct. They mustn't be. Okay, so we've got them right here, generic params. We just obviously forgot to add them to the struct. So let's do that. Let's add them here. This is the one with no body, but probably not going to have it on this one, but let's just add it anyway. Let's say a note probably never use, probably will never have params in this case. We can probably not include here. Maybe confirm. Okay, let's add it down the bottom here. So generic params. Let's add it here. It will be expression. Oh. Right, we'll fix this later. No, there has to be a hotkey to do that. I'm not sure what it is. Okay, let's see. Duplicate fit. What have I done? I added it twice. It was already there. Am I going blind or something? I already had it? What? I did already have it. Oh, this is struct declaration. I'm an idiot. On function declaration. Okay, so let's do that. Okay, here we go. Oh, this is what I wanted. Okay. Here we don't have it. So it should actually, no, it's passed in the type. So hang on a minute. It should be here in the type. I think it's all good. So if I go to, let's save this, pass type, function type. Okay, here we go, generic parameters. So this is basically the function signature. So yes, this is the function signature. Yeah, I use the scroll wheel a lot. But I broke my scroll wheel, which is quite annoying. Yeah, it's annoying that I broke the scroll wheel. But what can you do? It still kind of works. I mean, I don't need the scroll wheel, but alright, that's better. So now what we're looking for is why is this not erroring? Ah, okay. I need to remove this from here. That's better. Don't need that. Okay, this should error now. Yep. This will be function declaration, not type, dot generic params. Okay, that's better. So now let's see. Deferred. It looks like it's just completely skipped, which is very, very strange. If decl dot generic params dot length is greater than 0, let's just panic. Generic function. Type. Okay, so we've got that there. Let's do the same thing here. Okay, so we've got the same thing there. Well, why couldn't I see my what's going on? Why couldn't I see this? Okay, there it is. Deferred generic function A, B, C. Okay, so why aren't we erroring on the, probably not type checking. Let's see. So call expression. So checking these. Oh, let's check identifier. So this is the, so I've done a little hack here. This is why we're not erroring, because it's making all generics into strings. So get rid of that. Okay, unknown identity. Okay, so basically what I need to do is, when there's a call, Yeah, that's Zellage at the moment. I like Zellage and Alacrity, but I was also playing around this Wes term. The only thing about Wes term, it uses like a Lua configuration. Obviously, that gives you a lot of flexibility, but it's kind of rather frustrating. And there's a few little things I find frustrating about it. I don't know. I'm torn. It's more responsive a little bit than Alacrity, than Zellage, but I like Zellage. Anyway, let's return back to what I was doing. Yeah, Zellage is good. And what it normally looks like is like I'll show you. If I get rid of where am I? Look, let's get out of this for a second. Oh, there we go. If I open it normally, this is what it normally looks like. See, and it shows you all what to do. So if I press Control P, it gives me these options down the bottom. So I can say open pane to the right, and I can go P, open a pane to the bottom, open pane to the bottom. I can resize it like this. I can resize this one. This. Let's say I can hide the borders if I want. Show the borders. You can lock it. You can do some cool stuff. You can search, or you can dump the scroll back history into a file. You know, you can do some pretty cool stuff, and you can detach from the session. And now all the helpers, right? I'll show you something with if I get out of it and let's open this. You see this layout stream.kdl file? Let's open that. It's basically just layout. One pane, 70%, split direction, vertical, adding another pane. Because I haven't added a size on this second one, it just takes up the extra 30%. Now if I could add a size here if I wanted, but I don't need to. It will fill whatever's missing here. So basically I'd load it with that config and it just goes straight into my setup like that without all the helpers. Yeah, it's handy. So let's do, oh, I'm in the wrong file. Let's do, okay. And then I usually split my helix like that, rather than have two panes in Zellage. Okay, I can even make this a bit smaller, like maybe that. Yeah, that's better. My neck's sore. Okay, so we have this unknown identifier T. Now basically what we need to do is when we find these types, well firstly when we have a call, let me think. Basically we'll add these generic functions to a queue. Okay, we won't process them. No. We will process them. We will just make these named types. Okay, this can be a named type. Now when we have a call, we're going to have to match, we're going to have to infer the types of these, then create a concrete version of the function with the types from the call. Like if the call lists the types explicitly, then that's easier. Otherwise, if it infers them, otherwise we infer the types from the arguments. Okay. Just thinking the best way to go about this. It reads. I just load the config file when I open it up. It's very basic. I did have more complicated config, but yeah, it's very basic, does the job. So we have this, I don't know, ident. So let's check the parser quickly. Are you happy? I can also use page up and page down. So let's see. So we have an identifier. So let's add these generic functions to a queue. We'll add a little, let's add a little tag here, and let's call this function declaration. No. We also have to do the okay. What we're going to do is we're going to move this into a method. Let's move this into a method. Okay. Okay, let's add it here. This stuff will all get organized and moved into separate files appropriately and things like that. Let's call this function. Let's see, check our function declaration. Let's call it function declaration. Oops. There we go. Okay. So now what we'll do is if declaration dot type dot generic params dot length is greater than 0, we're going to add them to a queue, otherwise we'll process it directly. Okay, so what we're going to do in this case is let's try we could use our later method, or we could just do C not later okay, We can do C dot function declaration. Okay. So for generic ones, we are going to make them later, and we're going to add a tag here. We do function declaration generic. Okay. Now let's add a deferred kind here. Function declaration generic. Okay. So function declarations are done here at the end. Now we can do generic ones as we see fit as well. So, oops, let's do generic. Generic. Okay, let's not actually do it for now though. What's this error? Undefined ID. Ah, I forgot to put a dot. 209. Thanks. Okay, so we have got to the call. Okay, this is beautiful. So actually that's not gonna work. Let us reconsider what we're doing here. Okay. Maybe we will register the name of the function. Let's see. So what do we normally do? That's the body. Function type. Name. Okay, so we can do that. But let's see, function type. Okay, so we need to add generic parameters here. Okay. So we've got params. Let's add generic params. Okay, so let's do generic params, which will be type, and we'll have a type called named type, which will just be generic parameters. Okay. Now I know what I can do. So basically, what I'll do, let's go to types. Types. Let's add a new type. Let's just call it look, you can change the name of it later. Let's just call it named type or T type, or look, let's just call it name type for now. We'll fix the name of it later. Let's just call it just add it here. named type. This will be a generic, let's do T. I could even use an alias to string, possibly. Maybe it could just be that. Like it could be, I don't know if we need more information, but we could have type named type to string. Let's try that for now. Oh no, I've done it again. Alright. So let's have name type here. I need it in these other places as well. Need it here. And need it here. Well, I'll tidy this up soon. Okay. And we add a name for it. Let's add a name method. Let's add it here. Let's do name type and just return the t.string. Okay. Oh, I probably don't even need to add the. I don't think I need that. That should work, I think. Where are we? 209. Okay. What have I done? Name type. Named type. Did I save this file? Maybe I didn't save it. No, I didn't save it. Okay. The compiler is written in V. The compiler is written in the language itself. The backend it generates C code, which is then compiled by a C compiler, but this is written in V. Now this new one is going to be able to output machine code directly. Well, that's the goal. My neck is really bugging me. It's all twisted up. Okay, so basically, so we've added this named type, okay? Now, when we pass these generic parameters, what we can do is now what we'll do, let's do for generic param in function type generic params. Let's do if param not is st.ident. Let's do a little c.error with was expecting identifier. Let's just put 0 position for now. Let's do to correct position. Okay. Otherwise, generic params will be. Let's do. Actually, this can just be named type, and we'll do named type generic. Okay, let's do if is, and we'll do this. Otherwise, we'll do error. Okay, that's better. Generic. Okay, so we'll add those to there. Set it here. Okay, so open this. This can be function declaration. No, function type, which is just a function signature. Where is it? Where is it? Where is it? Where is it? I should just search for struct. Okay, there it is. So let's have, oh, I've got it. Generic params. Now, oh, it could just be string, I guess. That might be even simpler. But let's use our own type so we know. Let's do named type. Okay. We don't even need use a song type. Okay, let's do that. What is this? Cannot cast ident to name type. Well, I can if I do, instead of doing that, it's got to be .name. Okay, cannot assign generic to the name type, not string. We don't have string. We have a name type. What's going on here? 521. Interesting. I'll tell you what, let's just let's use a string for now. I just said I could just change that, but I don't think it's going to be used anywhere else where we need. Let's just see how this goes. Let's copy that. You might not need the extra type because I'm doing this manually here instead of using the ident method. So I think should be able to get away with that fine. Expected string, not name type. Can I save this? Let's make this string again. Okay. I'm back in 1 sec. Oh, sorry, yeah. It's in my repository, but I haven't actually I haven't pushed the commit, which like all the type checking stuff is not on GitHub, because once I've cleaned it up and stuff, I'll push it. It's a big mess at the moment. Okay, so where are we? All right, so we're just using strings for now. Now we can fix that later. Or we might be that's irrelevant now. It was just a string anyway with an alias string, so we've done that. All right, so we have it on the function type. Okay, so let's go back to function declaration. Where is it? Function declaration. Okay, so now we have our generic types here. Okay, so now we can check. We can say if, hang on. Yes. We can do, all right. So we should be able to do, when we're passing this function body, all the parameters, hang on, let's go back to function type. So what's going on? So we're checking them here. No, where is it? Here, yeah. So basically, we could probably avoid that altogether. We can do if, well, let's try something. Let's say if, let's say if param dot type is dot identifier, well, which it will be. How can we say this? Unless let's see, I could pass something to the ident method, or I can just do this manually. Let's see. So if ram.type.name in generic that's what I need. That's why I wanted the generic type. Okay, I remember now. Yeah. All right. So let's just, I still have that named type. Okay. So if this is in here, what we're going to do is we're going to say it's a named type. Named type. And we'll do param.type.name. Okay. Else we'll do what we normally do. Okay. So for generic types, this will get set to named type T, name, and so on. I might have to do else as well. Well, it's always going to be identifier. It's never going to not be an identifier. But that's not going to compile like that. Can I use as object and argument to the scope instead? So if I cast this to a type, it'll auto cast to an object. Okay, need else here as I suspected. C.expression param.type. Okay, I'll clean this up because this is not very nice. Okay, so now in this case we have all, so what I should do actually is I can set these generic params onto checker, and then ident method could do a named type, and any named type We'll then, let me think. So what I could do is insert T. We'll defer the function body because that's going to give us grief, I think. We'll defer the body until we've collected all the calls so we know what types they're going to be. So let's do that. Later. Okay, so as we were doing before, let's do let's just add this. So we'll skip the bodies of generic functions for now. Okay. So now let's take all the generic calls, and what we'll do is we'll save those types, or we'll try and infer the types. Look, let's just take it one step at a time. Hi, Spy. We're trying to implement generics type checking. All right, so let's find calls. All right. So we want to find a generic call. So if the left-hand side is, let me try something. If left-hand side expression is t.generic args, let's do a quick panic. Got generic call. Okay, beautiful. So there we go, that's a generic call. So in the case of these generic calls, let me think. We're going to take the types that we've called it with, save that somewhere, and then with that information later, we will turn those generic functions into concrete functions. Monomorphize, I think the word is. Yeah, we're trying to do the generics as simple as possible. And I'm using the monomorphization method. And I was saying too also, that way that all stages past the type checker will just look at it like a normal function, a normal method. They won't have to do anything special. They won't care about generics. But we'll leave some metadata attached to the function to say this is an instantiation of a generic function, so that we'll always be able to tell that it's a concrete version of a generic function, but we shouldn't need any special handling or anything like that. That's the idea anyway. That's the hope. It should be very simple using this method. It should be. of course, there's always stuff that I haven't thought about, and there's things which, there's things which completely take me by surprise, I'm sure. But okay, so we have a generic call here, so we know that that's a generic call. Now, all we can do is we can say if let's do, so what we do is let's do generic types. So this is if we've supplied them in a list. So let's do type. So in that case, we will be able to get them directly here. So let's do for GA in left hand side expression for args. Okay. Generic types will be C dot expression GA. And then let's dump the generic types. Types. Print line or ePrint line. Let's use Spies method, then we can do it. Generic, easier to filter types. Okay. What have I done? Generic types, missing an E. Okay. Let's do a little one.text. Oh. Let's open that file. Actually, I should do just the errors. So 2. Let's open that file. Okay, where are we? Generic types. Okay, so we have integer, string. Okay, so basically those are these. That's here, integer, string. Okay. So Spies, to be honest with you, I have not thought at all about how it will work with cached modules. Just take it as it comes. I'm just trying to do it as simply as possible, and as cleanly as possible, and then hopefully it'll all just kind of fit together like a puzzle. Basically just swing and pray. I mean, I try to think as much ahead as I can, but there's certain things I just can't think about. But if I make it as simple as possible and as clean as possible and as ideal as possible, then it should have a better hope of working than other. Well, it's just I haven't even got to that point yet, so I haven't thought about it. I mean, the only thing I can do is make the generics implementation as the best it can be, and then I don't think, I'm not sure about cache modules. But I've already done other stuff which will make cache modules easier. For example, the way that namespacing works. Anyway, I can't see it. I don't see it having any type of negative effect with cache modules the way they work. I mean, it should just. I don't see there's any problem. I mean, it's the same with it'll just be like any normal code. If the code's changed, then you have to if the code's changed, then you have to redo it. But otherwise, all that could change is just the calls. And if the function signature hasn't changed, there should be no need to redo it. I can't foresee a problem off the top of my head, to be honest. So I wouldn't worry about it. Well, I mean, built-in only has to be reprocessed if the code's changed. Why would it have to be reprocessed if the code hasn't changed? And if the code's changed, I mean, what can you do? You could incrementally do it, only the specific bits of code that have changed, but I don't understand the problem. But what's that got to do with the generics implementation? It's something more with the cached implementation. I wouldn't worry about it. I mean, what's your actual concern though? Explain the concern. Like, your concern is that it's going to have to be reprocessed all the time. But just explain the concern to me. Yeah, they will be easily cacheable. I mean, it's just like normal code. I mean, if the code's changed, then you have to redo it. Just like any other code. I mean, it shouldn't be any different. No, they won't have to be repassed and rechecked all the time unless the code's changed. Unless the actual generic function definitions have changed. Well, the checker might not do the monomorphization itself. The checker is just getting all the types ready and everything ready that where the actual functions. Like the monomorphization stage will come later, but checker is the path that has to get all these types ready for whatever comes next. Or checker could just make a version of the concrete function. I mean, I don't see any problem at all. I mean, there's no if the user code adds more calls with more types, and those functions don't exist because there was never called with those types before. I mean, you're gonna have to generate them. You can't get around that. In any way, you can't get around that. Anyway, I wouldn't worry about it. I think you're worrying about something which won't be a problem at all. I mean, if you really that worried, you can even just namespace the cached files, like the generic files, in a way that it will see has this stuff already been generated for these types, and if it has, just completely skip doing it. I mean, we'll be able to do it. We'll figure it out. It's not going to be a problem. If I can make the generics implementation 10 times simpler, then getting it to work however we want should be fairly easy. I mean, you might have to recheck only code that's changed, I think. I mean, either way, the current checker checks over and over again for every type. So, I mean, it can only be as bad as the current one, or better. It's not going to be any worse. It can only improve. Like, I mean, that's how generics is done anyway. That's how like generics should be implemented, really. So, as far as I know, that's the correct way to implement generics. So, I'm not sure. I don't think it'll be a problem. I'm sure me and you can figure out a way to make it work nicely. I'm sure we can. So what was I doing? I completely forgot what I was doing. Okay, so we have these. What was I doing? Okay, so we have these generic types. Okay, so and these are because we have supplied them as arguments. But if we haven't supplied them as arguments, we need to infer them, and obviously we can infer them from where is it? These are the. We can do this up. Actually, let's see. I lost my place. We can do that from. Let's just cut this. Put this up here. See if that errors. Anything errors on that. All right. Oh, look at that. Beautiful. So this is deref on non-pointer. But let's not worry about that. Somehow Siri is doing something. Go away, Siri. Bye, Siri. Well, this was getting skipped before, and now it's erroring because I wasn't checking these arguments. Why was I not checking them? Must have been returning early here. All right, let's just put. Anyway, let's just put that back where it was for now. We're not interested in this for now. We're fixing this other thing. So we have these. These are the concrete types that were listed in the call. Otherwise, we have to infer them from the arguments. So, oops. All right. So let me think. So we've got these types now. What can we do? So what we'll do is we save these types into a place where, for example, on the checker, okay. And now we save it in a map. For example, T will point to the type, okay. T will point to the type. And then every time an identifier with the name type, like T, Y, whatever is called, we replace it with the type map that we have. Now, we could do that on the fly checking, or then we can run a little process that clones the functions. Look, let's just build it into the type checker, and then we can do that monomorphization later. So let's see. Let's let's look at the function definition. Oh. So I mean, we could save it here, but I don't really want to save it there. We could do, I mean, you could save it here into the function like calls, but I prefer it's a state of the checker. Look, we can move wherever it's stored. It's not a big problem. So let's do it on the end for now. Let's do generic calls or something. Let's do map string. Ooh, I'm gonna do map string map string type. I'm gonna do that. Map string type. Alright, so this will be the function name mapped to t parameters to the types, or something like that. Oh, I might store that somewhere else. I just want to test the theory for now. Okay. So call expression. So if we have the generic, okay. So let's move this for starters. Let's take that and go. Okay, so now let's go into the, see here we've found a function, okay? Now forget all this stuff here. This is poo-poo. That's poo-poo. Let's just ignore all this. Here, let's put a note. Poo. Okay, now that's clear. Let's paste this here. All right. So we can do if function dot generic params dot length is greater than 0. So we know that the function we're calling is generic. Okay. So now look. Actually, look. What we'll do is if we have generic args, but the function is not. Let's do if function dot generic params dot length equals 0. Let's do an error. C dot error with pause. Cannot call non-generic function with generic argument list. That's if we've tried to call a function that's not generic with the with this call syntax. Okay. So if it's not a generic function, we error. Otherwise, okay, it's a generic function. Now, let's save these. We're gonna have to do this globally, but let's just because of that error we were receiving before, let's just put it here for now. Let's just do it here, and we will, once we fix the other error, we can do it globally. Let's just do types equals type. Okay, so if if generic args, how do I say this? If I should have done this different, like if function dot generic params of len is greater than 0. Okay. Now I should have done else if they had expression is ast dot generic params Who's beeping? Who's beeping who? It's the neighbours. So I have to go pistol whip him in a sec. Just kidding. So what do I get rid of that? Okay. So if this else we got to get it from. So let's put a little note. Must. So what's going on out here? Alright, so we must infer from generic types from args. Okay, in this case, generic types provided. Okay. All right. So in this case, these go here. Well, this will be done above, but will be done. Move above to done globally once error is fixed. Okay. So basically, what's going on here? Oh, so otherwise we've got these. Otherwise, the generic types. Oops. Let's do. Let's do inferred. Of course, this is just the types, but we're going to have to actually work out what's what. What have I done? Generic parameters. I've called it the wrong thing. See, anywhere it's on a definition or a declaration, I'm calling it parameters, and anywhere it's on the call, I call it arguments. So that's the easy differentiation. If it's on the call, they're called args everywhere. If it's on the it's on the definition, then it's parameters everywhere. That's how we can easily tell by looking at the code what is the call and what is the definition. I think that's convention anyway. That's how it's named. So I've just kept that convention. If you're wondering why sometimes it's params and sometimes it's args, that's the reason. So generic params do not exist in all the sum type variants. I thought we're already in. What is this? If I meant to do this in here. I put this in the wrong place. So I'm gonna take this whole code, cut it, paste it into here. Let's paste it right here. Link. Let's move that down there. All right. And I didn't make it mutable. Generic args is this list, like int, string, whatever, like that. And the beauty of doing it that way is, as opposed to doing specific implementation for the calls, this and that, just generic args is just passed as its own thing. You can use it anywhere. So like, obviously it only happens with a call, but I mean, you can use the same implementation for structs, for struct instantiation. It's the same, the parser uses the same implementation, so it's quite nice. Anyway, so we have this code here, it's running, okay. Let's output this to one.text, and let's remove that one.tx, because it's annoying me. Okay, one.text, let's reload this, search for inferred. Well, I think in our file, we have provided the, no, we haven't. See, here we haven't provided types. For the first two, we've provided the types, and for the second two, we haven't. So here, ooh, where is it? I've gone. So here, we should have this, but we don't. What is going on? Did I save this? Let's try again. Oh no, I didn't do this. That explains it. Okay, we should get it now. Okay, let's reload this. Okay, inferred. Okay, so here we go. Well, these are not really the inferred types. These are just the argument types. But we can see that we have in fact got some types there. Okay, so we have the types. Now we can save those somewhere. Let us save them. We don't know what goes with what yet. Okay, but we just look at the declaration. So what we can say. So what we can say is, let's loop through the. Let's just do a little loop through the for param in function.type. Now, function.type is the function signature. See, the beauty of doing it this way is that this type is like a function signature. So anything from it doesn't have the name. This function, let me just show you something, Spy. I'll show you something. Okay. So we have see this function type here? This has generic parameters. Parameters return type is variadic and attributes. Sorry about that. And also I might make it so that the receiver is the first parameter. Anyway, that's up for debate, questionable at the moment, but I could put the receiver here. But anyway, this little function type, if I go to scope and we have, object, we have this other function here. We have name and we have type. Okay. This is a function like function blah blah blah, function blah blah blah. Okay. Right, but type, this function type really is this is signature. Okay, so that is from these curly braces on. So I mean from these parentheses on until the return type. That's what this is. So function literals, function fields of a struct, functions in an array, it will all be this type function type. And an actual function will be this with a name. Yeah, the receiver is the first thing I think is good. That's what I'm thinking. Nice and simple. Yeah, so I reuse everything. Exactly, that's the point. And all functions use that function type. And if it's obviously if it's a literal or something, it just uses that type. And an actual defined function has that extra layer with the name, and its type is the signature. Basically, you think of that function type as the signature. That's basically what it is. I should call it signature maybe, but it is function type. But either way, you can see everything's reused. Like okay, so we have these. So dot type. Okay, now we should be able to say for param in type of params, and we should be able to say if param dot param type, no, if param dot type is named type, which is what we call it, we might rename that to something else. Name type is like ty whatever. Okay. The xy, what do you think about x? What is that? I don't even know what that is. What is that? X, what is that pipe? X, comma, Y, pipe. Are you talking about, are they, I'm not sure what that is. Is that a new feature or something? Oh, okay. Yeah, I didn't even know about that, to be honest with you. I mean, I remember you were talking about it, but I didn't know it actually got implemented. I mean, I would make it have its own node if yeah, for sure. Because I don't want it to be treated as something else. Yeah, it would have its own node for sure. I did actually look. I did actually look to see if it would conflict anywhere with the infix expressions, and it doesn't. So it's perfectly fine to do that. It just seems like, I don't know, like if we were doing that, I would really like that syntax. We use that same pipe syntax for the variable, the scoped variables of a function literal. I don't know, or something like that. Because I don't like that. I know it's kind of like a list of names, sort of a list of variable names. I know it's a different function, but I don't like using the square braces. Anyway, I'm going into a tangent. So okay, if parameter type is name type, then we can say, let's say print line. We say generic. Let's say generic param. Actually, and what we'll do is let's do for I. Okay, now we can do parameter param equals function dot type params I. We don't have the receiver in there yet, so all these are functions anyway. But okay, let's do. Oops. Actually, okay, so we've got the parameter there. So this, say we can say generic argument, and we can say let's do okay. Now we have param dot type dot name. Okay, and we can have type dot name. It's like a mapping from the generic argument to the actual type. Let's have a look at this. Param does not return a value. What is this? Does not return a value. What do you mean? What's going on? Has no field type. Function type. Has no field. Oh no, I'm already on the function type. So what have I done? So I just need function. What am I doing? Hang on, I've messed up. I messed up. It should be this function. Alright, no, this should be generic. Hang on, what have I done? Param type. No, that's right. Okay, let's have a look at that. Actually, I want to see my my history up and down. I broke it, like the config. I got to fix that in the config. I like it where it completes from the exact last thing, not where it goes through history. Well, before I was using my ZSH, which had all those configurations with it. When I got rid of that, I was trying something else anyway. Okay, so here we got generic argument t, which is int literal. Okay, that's because we haven't made this to actual type yet. And string. Why is this string? This should be what's going on here? Let's print the function name so we can just see exactly what's going on. Let's do function name. Actually, what is it? So we have that here. Let's do call. Fuck, where is it? Expression dot. Expression dot name. Let's do actually. Let's open my AST. Let's do name. Okay, for expression at name, I've got that. Okay, so looks like we're getting an error here. Unknown field method call expression at name. So I have a call expression. Let's do well, let's do call expression dot left hand side. Okay. Oh. Okay, so here we go. That's better. No, what's going on here? So generic argument T in literal, Y is string. Let's look at that. So this is for generic function B. Generic function A, why have we got string here? This shouldn't be a generic argument. Shouldn't think that's a generic argument. So what have I done? I see. Okay. I know what's going on. So basically this should just be if. It should only print if param.type is named type. Otherwise it's not generic. Okay. So that should be better. Okay, that's better. So now we've got T maps to the int literal. T maps to, let's open this up. Generics. Okay, so generic function A. This is the call. These are inferred. Okay, let's look at here. Let's look to start with. So I didn't list the function. Now let me do that. Just makes it easier to see exactly what's going on. So let's do. Okay, so it's even that way. Okay, so I've messed something up. What have I done? Anyway, we can see what's going on. So we got generic function A. Okay, these are the lists. So we've listed it as int. Okay, we've got that. Generic function B. Okay, we've listed it as int and string. Okay, we listed it as int and string. Beautiful. Now these are these calls here. Generic function A. These are inferred because we haven't listed it in the square braces. So we've mapped T to int literal. Okay, so T, yes, int literal. That's correct. Or int, whatever. Y, okay, there's a problem. No, this is function B, so that's correct. Y is in fact string. Yes. Function A, where is that? Function A, okay, just T. Function A has just got T, okay, because B is just a string, it's not a generic parameter. Okay, so that looks good. That looks good. All looks good there. All right. So we have that information now. Nice and simply. we have enough information now where it should be as simple as this. It should be, in theory. It should be this simple, okay? We have the mapping now of t parameters to types. We have that mapping, okay? So now we should be able to change the identifier lookup method. Whenever it finds an identifier which is a t type, it just replaces it with a type from that map. Now that would be kind of like how the current checker works, where it does it on the fly. The other way to do it would be the monomorphization way, is where you actually go through the function, find all identifiers, replace them with the correct identifier, and then you change the parameter types, the correct types, and just make a copy of the function. But first we'll try just the checking method by changing the types, just to see if that all works, and then we will do monomorphization or whatever. That the monomorphization is irrelevant. Once we have basically just this information, however, we could just make copies of the functions. That's not a big deal. That could even be done by another stage or by checker or just another. However, it's a very simple process. I'm oversimplifying everything, but it should be this simple, really. It shouldn't be complicated. Of course, there's nuances and things I'm not thinking about, but if it behaves like a concrete function, it makes things a lot simpler. So we have the mappings, okay? Let's save that into checker. I'm just going to save that onto the map for now. Okay, so I could save it with the type, but I don't. No, I don't want to save it onto the type because it's just for this call. So what we're doing, we need an array. Let's have a look what we've done. So we've got, we could do this, we could put it on the type, but I'm just going to put it on. It might be better to put it on the type, I don't know. But I don't particularly like that idea. Let's see. So we could have like generic types. Like generic types. It could be like an array of map string type. And for every call, you can have a mapping of the types. I don't know if it's better to go onto the type or not. I don't know if I like that. I think it might be better to go on checker, but then you've got the extra lookup, the extra map lookup. The opposite of that is you've got this extra information and all the time where it's not needed, this extra memory for the map and the array. But this is easy to change, however, we can just figure that out with what we feel is best. Maybe let's just save it here for now. Medsave's doing this lookup, which is easier for now. Let's put a little to-do. Save in checker.env or here. I think I prefer checker. Okay. Oh, I broke something. What have I done? I don't need that. Okay, so let's go to call expression. All right. So, we didn't check the return type either. Well, we'll do that. Okay, so let's check that. Let's check the return type above. Where is that happening? If I've got to really do all these things in one place, not multiple places. But I'm going to go through and clean all this up. I just wanted to get the basic functionality working, and then I go through and clean everything. That's why I haven't pushed anything, because I don't like to push things in the mess. I know I shouldn't do that. But the only difference between what I haven't pushed and what I have pushed is basically the type checker. It's got out of hand now, not being pushed, but it's a big mess, and I want to clean it up. I never pushed anything that was a mess before. That's why I don't want to do it now. I mean, into the TinyB repo. Okay. So let's check if well, if actually no, I don't need to do that yet. I don't need to worry about the return type yet. That's okay. That will be no. Don't worry about that. That will happen later. Well, I should have done it in the function declaration if it was a T type. Well, let's go back to that function type. Here, if return type is T type, like I've got here, I've got see if, where is it? If it's in generic params, then make it a T type. I'll do that with the same with the return type. So where is it? Return type. Okay, so let's take this and put this up here. Okay, so return type. Let's do if type, if RT equals function type. No, this is an expression. Hang on. So okay, yes. So let's do mute. Okay, now let's do if return type is no. Actually, fuck. Sorry. If type return type is AST dot identifier if function return type dot name is in generic params in function, where is it? In generic, in type, the generic param, in function type, where is it? Function type dot generic params. Okay. What have I done? Huh. Wait a minute. What have I done? This highlighting is annoying me. Ah, that's better. So, where's the arguments? Here. In generic params, then use a name type. Okay. So, it's ident and the name in generic params, then named type function type return name else c dot expression well, I should just do I should just do, maybe I don't need to run the expression otherwise. Then I got to do an else here though. That's a bit annoying. I'll clean this up. I don't like that. Having to do the same thing twice. I can probably reorganize it. Yeah, I know. I messed up. I messed up by doing that. But it's only really one file that I've changed. Yeah, well, and other little files, but the bulk of it is just checker. I know I shouldn't have done that, but it's just such a mess. I don't want to push it, and I didn't want people to start adding to it because I know it's just stuff that, yeah. I did. Yeah, I shouldn't have done it. As soon as it's cleaned up a bit, I'm gonna push it. What have I done? Okay, that's better. So that's just setting the. This needs to be cleaned. All right, so map t to type. Okay, let's just say map. Let's do t to type. Map named type variables to named type. No. What am I doing? Array of the type. Let's just say that for now. Now let's say here. If param type is generic named type is generic, replace ident with named type. And we do the same here for return type. If return type is generic, place with name type. Let's just say replace with name. It's not an identifier that we're replacing. Okay. Yeah, you're right. I messed up a bit. All right, so we have that now. Let's just save. Let's go to our core. Oh, yeah. We'll save it there for now. So let's go back to the top. Let's just comment that for now. Let's go to call expression. Okay. So we've inferred them here, and here we've got them in a list. So in either way, let's save them to a mapping of T types to, so you need let's make a map. Okay. Now in this case, we have generic types here. In this case, we have so in this case we can just map it one-to-one by, let's do I. Okay, and now let's do generic ram equals function dot generic rams I. Okay, so this will be, let's do generic type. Okay, this can map like this. It'll be generic ram, let's fix that. Ram equals generic type. In this case, it'll be generic type map param dot type dot name. Actually, this can go in here. That just goes in there. Equals. Actually, it'll just be, if it's name type, then we just need name. No, it's just, we just convert it to a string. I think that will work. I don't think we need to call the string method, do we? I don't think so. Okay, so then we got we're gonna map this to archetype. All right, now let's just dump this map. So in either case, let's dump the map here. Let's do dump generic type map. Oh, let's set it onto the function dot generic types. No, this is going to be an array of, oh, it is. Let's do okay, let's dump it also. Let's dump it first here. Shit. Let's make this mutable. Okay. Okay. All right. Where's our dump? Huh. Where is it? Where's the map? Why am I missing it? Map. Oh, here we go. Generic type map. Well, this. Well, let's just do. All right, so. For KB. Why is it? What have I done? I've done something stupid. Why is this here? This should be. I've mapped the wrong thing. What have I done? No, that's right. I think this one's wrong. If parameter type is named type. I killed it. Oh, that's better. Okay, so yeah, we've got the map here. We saved it onto. So we'll be saving it onto the function there. Okay, so now the function. That's not a great place to save it. I could save it on the check. Anyway, look, well, I'll move it in a sec or something. So we have the information from the calls. So now we can do something like this. Just for example, let's try and let us do. So we have that information. Let's go to function declaration. Okay, now, oh, but there could be more in generic functions. There could be more calls in the generic function body to generic functions. So we'll queue those, but for now, we are we're not worrying about that. Okay, so what we'll do is let's call this deferred kind equals if the goal dot type dot generic hammer dot len equals 0, then dot function kind dot function. Oh, I finally got some completion. Well, let's just double, just greater than 0. Let's say function declaration generic else. I wonder if for the second one I can just do, doesn't matter. Okay, so we got that. Now let's put that here. All right, so we are not processing those yet. So let's go to the top where we process the this is the generic functions here. Let's have a look. So let's go back. Actually, we might not even need to do that now. Let's go back to function declaration. Okay, now let's say if we got generic, right? What we'll do is let's set c dot generic. Let's just check we've got the right information here. Let's print line. Let's do print line. Print. Actually, we're not going to have this information here yet. But let's just see what happens when we do type dot generic. I don't know if I save this. Ah. Is this saved or what? Oh, this is the AST. My bad. Oh, hang on. That's the. So I need to get the name. Let's see if it's. Let's try something. Let's do. Actually, I already have that here. Let's do type. Oh, my bad. I'm just rambling to myself. There's no sound. Sorry. Oops. Thanks, bye. Oh, sorry about that. Oh man, I was just rambling on, rambling on. Oh, so what am I doing? Let's just undo this rubbish. Function. Now that should be. Let's just try something out of interest. Not that that. Oh. Change a bunch of stuff. Oh, no. Didn't mean to do that. Let's try this. Can't do all this stuff right now. I'm just doing it a different way for now. Alright, anyway. So, let's do... I'll fix it later to use the proper reference and stuff. But this is just a proof of this ident.pos is not used. There's no. This is rubbish. This is not used, and I'm not going to do any internal lookups. Only lookups that go towards the parent. So this should never be used. The positions should never be used. So it should always be fast lookups. I might even get rid of that from this method. I don't think we're going to need the positions anyway. So let's just see. Let's just call this T for now. What have I done? Oh, I'm processing the function bodies. Let's just check. Let's check this. What's going on here? This is strange. The 0 means nothing. It's just I'll get rid of it. The 0 was to do with a position. It doesn't use that. The 0, that the position is for inner lookups, like where you got to find or within a certain position. I don't use that. That lookup just goes up, looks in the current scope, doesn't find it, goes to the parent, looks in that scope, doesn't find it, goes to the parent, etc. Well, look, let's just save this somewhere else for now. I'm just going to save it here. Let's do... Right, let's do that. Let's go to types. I need to fix the references and stuff. I need to look into that to make sure everything's working as I suspected it should. I will test that later. Let's go to... So where are we? Let's see. Just make sure this is right. That's what I expect it should be. What have I done? I've commented the wrong thing. What did I do? What did I do? Oh, I commented the wrong thing. What? Huh. Generic calls. Let's just call. Oh, let's, yeah. Let's call generic types. Okay. Okay. All right, that's good. So now let's go to function declaration. What have I done? Okay. So here, let's get that out. If Actually, what we'll do is we'll say this is our overloaded functions, which I haven't done yet. Just it's an empty function. Anyway. Okay. All right. Oops. Okay, here we go. So we have these types here now. T points to the type, etc., etc., etc. Where is the Y type? Y points to string here. Okay, we'll set that. Let's set that onto. What we can do is, so we've got that there. Let's set the current generic types to. Let's set to. Let's add a few like current generic types. Can be map string type. Now okay, so we will do, let's set okay, so now let's go to the identifier method. Whoops, what have I done? Okay, so this method here, we can see here, like what we can do is, if okay, let's fix the highlighting first. Okay, so if the ident fails, so it does a scope lookup here, right? Now if it fails, don't worry about that. But if it fails, basically what happens is it checks these things to see if it's one of them or if it's one of those. Otherwise we error. Whoop. But what we can also do is, where have I gone? What we can also do is, we can say here, if ident.name in, right, c dot current generic types, then we know that that it is we know that it's, well, what we can do is we can just say, we can say if generic type equals c dot generic types ident dot name. Okay, we can just return the generic type, and we can just say print line. So we can say found. We can just say matched. We just say replace generic type ident dot name with, or was just say let's use the proper things. Name, okay, so like that. Okay, so that's the basic basic principle. Okay, so basic should technically work. What have I done? I put it on M, didn't I? Did I? Yeah. That doesn't need to go on M, that can go on just normal. I think that doesn't need to go on the end, but I'm going to move it from here anyway. This is just to test if it works. Oh, hang on. Yeah, I need to do and okay. So what I do is for enc.m car generic types. Okay, in what have I done? What have I done? What is this? Hang on, that's the wrong error. Hang on a minute. So we got, okay, I know what I've done. These should be okay, it should be like that, and okay, what is this? What's this? Oh. Oh, this should be an array. Wait a minute. What have I done? What was I pushing onto the... Oh, it is an error. What have I done? Current generic types is the array maps, and this is, what is this, an array? I have the array, I have this item here. That should work. I don't want to do that. I want to override it. I want to append it. I want to override it. What's going on here? Non-integer index string array. Oh, hang on. I'm an idiot. I put this in the wrong place. Never mind. I meant to do this. That's better. So where's the other place? Where's the other place? Is that correct? That's correct there. Okay. Let's try that. That's better. Okay. So looks like did our error go away? Our error went away, I think. So I think our checker error went away. See, whoa, that's a problem. Oh no, here we go. Replace type T with string. That I don't know why that is. Oh, because that's the name. I haven't this doesn't have. That's wrong. Hang on. That's something. Whoa. Functions. What have I done? Huh? Oh dear. How did that happen? Oh. Oops. No. I didn't done that here. Oh, what have I done? That's right. What? Oh, hang on. That is strange. That's better. Okay. So, of course, these literals, they're just not promoted the right thing. But you can see here, if we open this, if we open this file here, we can see that these calls here, well, these two calls, right? So we are missing something here. So we had, well, the first call is here, t gets replaced with int, t gets replaced with int, t gets replaced with int, y gets replaced with string. Yeah, that's looks like we're missing one of the missing one of the things. Yeah, we are. Thought so. We're missing the last one. But multiple. So what's going on here? Ah, yes. I'll function. Okay, that's fine. We just that's just my errors wrong. We're just not skipping it in the right condition. Okay, let's have a look here. Okay, so something strange is going on. Replace T with the interliteral. Okay, that's here. These are these. Okay. So we got T. This is these ones. My bad. So T is replaced with interliteral. T is replaced with interliteral. T is replaced with interliteral. Y is replaced with string. That's what these are. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now, as I do this, I can do the same thing, right? Instead of doing this, I can take that function body, I can clone the function, update the parameters with these, update the parameters with these types, update the return type with this type map, loop through the function body, find all the identifiers, replace them using the same map, and then the clone function, that's the monomorphized function. So yeah, obviously this is just naive and basic, but this is just the basic idea, you see. I'm going to jump off stream for a bit. I got a couple things I got to do, but I'll jump back on later and we'll continue on from here. Thanks for watching, everyone that's watching. Yeah, I appreciate you guys coming in to watch, and we will continue on later. Thanks, everyone. Thanks, Spy. Thanks, Daniel. See ya.